Hi, I am Tanya from Forgrants and Saratai. Today we are diving into the AI-powered feature Smart Locators into tools like Testim, Applitools, and Mabl. Mehmet and Fatwa will walk you through the real examples showing you how these features work and how to test them effectively. At the end, they'll all share a quick summary of the pros and cons. Stick around and enjoy the showcase. As always, if you have comments, ideas, or questions, drop them below. We would like to hear from you.
Hello everyone and welcome back to another video by Forgan's AI Task Force. Today we are diving deep into one of Testim's standout AI-powered features, Smart Locators. When I first started using Testim, I was intrigued by how it tackled one of the biggest challenges in test automation, locating and interacting with UI elements reliably. In traditional automations such as Selenium or Playwright, test scripts often rely on static locators like XPaths, CSS locators, or IDs to identify the web elements on the page. But here is a problem. In agile development environments, for example, these locators can change frequently. A small update to the DOM structure or renaming an element can cause your tests to break. This is where Testim Smart Locators, powered by AI, step in. Smart locators work by analyzing multiple attributes of an element and dynamically creating a robust selector that is less likely to fail if the UI changes. It understands every element and how they are related to each other. For example, instead of relying only on elements ID, the AI test team looks at additional attributes like class names, hierarchical relationships, text content, and more. It essentially, by the way, builds a composite understanding of the element's identity, making your tests far more resilient to changes in the application. Now you might be wondering, where does the AI fit into this process? Yeah, of course. The AI in Testim doesn't just create these locators, it learns from how elements behave and evolve over time. Now, let me explain this better with a live example. First, I put a breakpoint on login button and then rerun the test again. So it's still loading. So after filling the username and password fields required when logging into the Forgans demo webshop, before clicking on the login button, we have reached to the breakpoint, and now I'm making some deliberate changes for a login button in the DOM. For instance, renaming the button, changing the text and the ID, etc. So as you see, the login button name has been changed. And then I will continue the test. Yes, now it's now ready. So let's continue the test. So as you can see, the test continues successfully step by step and finally reach to the end without any error. So what does it mean? That means the smart locator still worked. The AI's ability to understand the elements in context meant I didn't have to go back and manually fix the locator every time a small change occurred. Since Smart Locator has already detected multiple DOM attributes of login button, so even if some of them are not matched, the test won't fail. For example, this score tells us that some attributes are different from the baseline. That's why we don't get this score 100% here. Now, let's talk about the advantages and disadvantages of AI-powered smart locators in Testim, based on my experience and what I have observed. First, let's start with the advantages. One of the biggest strengths of smart locators is their resilience to UI changes. Unlike traditional locators that break when an element's ID or class names change, smart locators dynamically adapt by analyzing multiple attributes. This means fewer flaky tests and more reliable automation. And another advantage is reduced maintenance. Since the AI automatically adjusts to minor changes in the DOM, you spend less time fixing broken tests. The self-healing capability is also a standout. It automatically detects and suggests fixes when a locator fails, saving even more time. Smart locators also significantly improve test stability, reducing the headaches caused by flaky tests. And perhaps most importantly, they are easy to use, allowing even non-technical testers to create robust tests without writing code. And this makes test automation more accessible across teams. Now let's look at some disadvantages. First, there is the dependency on AI. While smart locators are highly effective, they can struggle with very complex or unconventional UIs, which might lead to failures. And another challenge is the black box nature of an AI. Since it decides how to locate elements behind the scenes, it can sometimes be hard to understand or debug why a locator is failing. And additionally, major UI changes like a complete redesign. This may still require manual updates, even with the smart locators. And finally, in very large or complex applications, the dynamic recalculations of locators might slightly impact test execution speed. To summarize, the relationship between smart locators and AI is all about adaptability, resilience, and efficiency. The AI analyzes, learns, and adapts to changes in the application and giving us a tool that evolves alongside our code base.
Hello everyone and welcome to a new video from Foreground's AI Task Force. My name is Federizika and in this video we'll be looking into one of Mabl's AI feature. And specifically it would be the smart locators, or basically how we can find an element when we are testing. So assuming we are going to create a new browser test in our demo web shop. So how does it basically identify elements or find the elements, especially if there are a lot of elements when we are recording certain steps in our test? So I'm doing a browser test, and let's say I'm going to the shop. And obviously in the shop we have a list of items and we can add them, and the button actually looks the same in all of them. So when we're recording, let's say I added the 3-speed bike and I will add the headphones, right? So obviously, as you see here, it tells you that it would be better if you do provide more context, since it does seem from the outside that it's the same buttons. But it does clearly identify it. So let me explain how. The smart locators, let's say, work in Mabl. So if we actually edit the element, we can easily see the details of the element, and practically it's every detail that we would need to identify an element. So what is the tag of it? What is the text used? The XPath of it? Class name. And you can see that it got everything in the class name. The area label, which as you can see does have the 3-speed bike, so it would understand that which one it is, and the styling. And on top of that, it even has the element right above it, which is a list, and it is a 3-speed bike. It even has the XPath for it and the class name that it needs. If we check the second button that we did add, then you would think it has the same information. But the area label is actually different, and obviously the ancestor element is also different, and it clearly identifies it also in its XPath that it is different. So more or less, it identifies, let's say, the whole DOM when we are actually clicking or, interacting with any element. On the other hand, though, Mabl did not really specify this more or less of an AI, so maybe we can look into it as more like an automation thing. But let's say we want to check the cart after we have added. So there's another way where you can also find the elements. And the problem though is it's a bit more limited. So either you can find the first or last element. So if I have more than one product and I want to like remove the one in the middle, that could be harder. That's one part of it. And the number of elements is important because if you want to do any sort of looping, then this is helpful. But the query type is only the CSS or the XPath, which really means that basically not find as much as you would think you can, or at least not be able to choose all of them. Also, it does not have more or less a DOM structure. Now, as you can see, it has two elements, right? Because it's also the same case, it's a list and it's written the same exact thing and so on. So in a sense, that helps if you just say it's the first element or it's the last element. So if it's the last element, it will choose this one and so on. So I'm removing the last element, right? Now, the difference though is if I try to edit that, I don't have the whole DOM, more or less. So for any reason, if anything did change in the page, right, then there would be this problem that it cannot locate it, right? It can't do the auto healing. And in fact, Mabel specifically mentioned that if you specifically found an element in such a way and you specifically said that it's a CSS with a query type of CSS or XPath, and that's the only identifying way of the element, then for any reason, if the page structure changed, if something happened, then it would not be able to actually find it because you specified a specific path to it. But in the auto healing, it's kind of using more or less the DOM to identify it. It's not just one way to identify it. And if we do run this test, more or less, as you can see, it's clearly identifying which one is which, even though from the outside it looks different. And as you see here, yep, and it also got the last one since we mentioned that it is the last one. But technically, as I said, it has this downside that if you're using the finding element because it doesn't have the whole element structure and information like it did, it could fail more or less in the auto healing. But it basically gets all the information while we are recording in a browser test that it can easily identify that even if it changed its position or something happened, it does not visually look the same. It can still auto heal it and be able to find the exact element that we are pinpointing. That has been all for the smart locators in Mabl. Thank you for your time and attention.
Hello everyone again. In this part of the video, we are exploring Applitools pre-flight, focusing on its AI-powered visual locators, which is a feature that enhances test automation by making it more robust and less prone to errors. In traditional test automation, tools like the Selenium or the Playwright rely on static locators such as the XPath, CSS selectors, IDs or class names, etc., to identify and interact with elements on a web page. However, in dynamic and rapidly evolving applications, these static locators can become unreliable. A minor change, for example, in the DOM structure, like renaming an element or altering its position, can cause tests to break, leading to increased maintenance efforts and reduced efficiency. Applitools addresses this challenge with its visual locators, powered by advanced visual AI. Instead of depending solely on static attributes, visual locators identify elements based on their visual appearance and context within the UI. This approach allows the AI to see the elements as a human would. Now, let me show you how we can record the test process first and add some visual checkpoints during the recording. So we start the recording process by giving first of all the target URL and then click the start test button. And here is a very basic demo that shows us how we log into this Forgans demo web shop. First of all, we are starting to give the username and the password. As you see in the right side of the window, the credentials are being saved. Now we can drag this flag to the target button or the element to check this element visually. And we can also add a text assertion as well. Now we are clicking the login button and the login process is done. Now I will also add another visual checkpoint. So just drag and drop and another text assertion. Now, as I said, it's a very basic test. Now let's sign out, log out, and okay. The, to finish the recording, we just need to click finish the test button and then we can save the test. As you see, as soon as we save the test will be run immediately. Okay, so as you see, the test is now queued and running. Here from the top menu, we can also take a look at the test steps. For example, I added at this step 5 a visual checkpoint. Here is the visual match in percentage, 95%. And if we go inside of a test step, so we should notice that many attributes of a web element are saved during recording by Applitools. And here, for example, we can also set a waiting time in seconds before performing any action. And yeah, also some other settings. And here we can also disable auto healing if we want to. And after that, we can also watch the video of the test process. It is actually very helpful to be able to detect if any error occurred during the test process. A very helpful feature for debugging actually. I changed the location and the text of the login button where we added the visual checkpoint in Forgan's demo webshop. Now let's take a look at how Applitools will detect. There you go, it raised an error. Checkpoint no match. Visual match is 69%, but the required one is the 95%. So what should we do? Okay, let's dive into it. Okay, there you go. On the left side, we are looking at the baseline image. On the right side, we are seeing the latest test image. As you see, the login button position has been changed. In the right side menu, we can set a new tolerance or the allowed value so that the test will not fail. From here, we can also change the checkpoint type, such as checking the value or grabbing a value. The test step type can also be updated from this menu. But now for this demo, let's stay in the checkpoints. Let's apply it and go back to test details. And now let's rerun the test and see the results. Okay, it's queued first of all, and now it's running. And let's wait a little bit more for the results, and there we go. The result is success. Why? Since we have changed the allowed difference value. Yeah, this is the visual checkpoint. As you see, the image match is 69%. But as I said before, since we have set the new tolerance value in the 40%, that's why the test did not fail. In the summary part, I want to compare the advantages and the disadvantages of AI-powered visual locators in Applitools. This feature offers a range of impressive advantages. One of the most significant strengths is the resilience to UI changes. By relying on visual attributes rather than static locators like IDs or XPaths, visual locators can adapt to modification in the DOM structure. For example, even if an element's ID or class changes, visual locators still identify it correctly, ensuring fewer test failures. This adaptability significantly reduces the maintenance effort typically associated with fragile locators in the dynamic applications. Another key benefit is the self-healing capability. When a locator becomes invalid due to a UI update, the AI automatically detects the issue that adjusts to find the correct element. This features ensures tests remain stable and reliable even in fast-changing environments. Additionally, visual locators use AI to see the elements as human would, analyzing their visual attributes like shape, size, and position. This human-like understanding enables the tool to handle UI updates that would otherwise require manual intervention. This versatility makes them applicable across a wide variety of use cases, from simple web applications to complex interfaces with visually dynamic designs. So we can also mention that it's very easy to use also for non-technical testers. However, there are also some disadvantages of this feature. Their heavy reliance on visual context can be a drawback in a minimalistic UIs or designs where elements lack distinctive features. In such scenarios, the AI may struggle to differentiate between elements. And another challenge is the black box nature of the AI, which can make debugging more difficult when locators fail unexpectedly. Furthermore, processing and analyzing visual elements require additional resources, potentially leading to performance overheads in visually complex applications. In the edge cases where elements appear identical or in unconventional UIs, visual locators may encounter difficulties distinguishing between them. This lack of flexibility can be a limitation in highly specific or unique testing scenarios. And additionally, while the tool is intuitive, there is a learning curve when it comes to maximizing the capabilities of visual locators, particularly in edge cases or complex workflows.